What, ladies and gentlemen, is a prism? A 3D object. Okay, so hold up a moment. Hold up a moment. This has 3 dimensions, yes?
Yes.
Does it or doesn't it? Is it a prism? No. So, Austin, you have the first step of the prism definition right. It is a 3D object. Refine that. So, it's a 3D object, but we need more because a spoon isn't a prism. Straight lines. Okay, I like that. There are straight lines. Okay, let's keep brainstorming for a while before we commit to writing it down. Straight lines. What else? What? It's got what? A shape. Okay. And what did you say, Austin? Because between the two of you, I really like that answer. What did you just say? Faces. Excellent. Good. What else? Well, that's 3D, so it must have a volume. It has to be round? Yeah. This is not a prism?
No. Yeah.
Is it or isn't it?
No.
You're not in trouble. That's not a prism.
Yes, it is.
You keep changing your mind.
It's a prism.
But is it round?
No.
So we don't want to lock into round. All right, keep going. What else?
Wait, I don't know if it's a prism.
It is. This is a rectangular
How
prism.
is it a prism?
I'm getting to that. We haven't defined it yet. Edges. Yeah, edges. I think Gervier talked about... No. Austin had straight lines. Excellent. Okay.
I'm thinking of spheres.
What else? And Gervier had faces. Definitely this has faces, yes. What are all those faces?
Sides.
What are all of those
rectangles.
rectangles?
Squares.
Excellent. Is that a rectangle?
That's a square.
No, it's a rectangle.
Oh.
Is that a rectangle? Is that a rectangle?
Yeah.
Right? Everyone agrees?
Yes.
Okay, so if that's a rectangle, that's a rectangle. What's this?
A rectangle.
What's this?
Rectangle.
What's this?
Rectangle.
What's this?
Rectangle.
So, is a prism a 3D object that starts with one shape,
And
ends with the same shape, and what's between them? No.
a different size of shape?
You're so close.
Different size of face. Smaller?
Okay, let me change it. What if I had...
Different length?
Just wait. I need a piece of paper that I can fold up. Okay.
Woo.
You guys are so close. I'm actually very happy. Usually classes don't get that close that quick.
You're welcome.
What do I have there?
A triangle.
Agreed?
Yes.
If I repeat that triangle out to here, what? Yes, but what is between this side and this side?
A triangle long.
A rectangle. What is between this side and this side?
Rectangle.
What is between the bottom and the bottom?
A rectangle.
So, it's a 3D object which starts out as a single shape
And
that repeats, and what separates them?
rectangle.
Rectangle. Good. So a
What
3D
was-
object.
What was so close that I said? What was it that was so close to that?
What did you say
I said
exactly?
it in this shape of
A different shape. That's what you said. But it doesn't.
a longer shape.
A longer shape. That's what you said. Yeah. A 3D object starting with a polygon, because it doesn't need to be a triangle or a rectangle or anything, right? It can be any shape. Starting with a polygon which repeats and is separated by what?
Rectangle.
And is, I can't spell separated today. Separated by rectangles. Now, I would like to thank all of you for joining me on that discussion, because certain people in the other class just grabbed their phones and typed in definition of a prism.
How did you let them do that?
Well, no, I did it on purpose, actually, because as soon as I saw people reaching with their phone, because the definition that you get when you hit Google is, it sounds like Greek. You wouldn't understand it. So it's a useless definition. This definition we all get, don't we?
Yeah.
All right, so let's start with an easy one. Let's draw a rectangle. Everyone agrees? That rectangle is going to repeat, isn't it? On paper, I can't draw straight backwards, can I? So what do we do on paper to show depth? We go diagonal, right, Dan? So I'm going to go diagonally, and then that rectangle is going to repeat again, correct? And they are separated by rectangle there, rectangle there. Everybody with me? Everyone agree? Okay. That is a rectangle prism. Easy. Because it started with a rectangle. Now, what if that one I just made, I showed you guys with this example. Can I start with a triangle? Can I repeat that triangle back here? Now, I'm not going to draw the other sides of that back triangle because you wouldn't see them, right? But if I connect them, isn't that a rectangle?
That looks like a tent.
Exactly. It looks like a specific kind of tent, a pup tent. Yeah? Everybody with me? I like to use that because not everybody's gone camping, and most people that go camping don't use that kind of tent anymore. Like a bivouac thing. I use the Toblerone chocolate bar because we've all had one of them, yeah? Starts with a triangle, and then there's like 20 of them. And when you get a Toblerone, you should share. You should give one piece to all of your friends. But no, of course not, because you eat one bite, you're like, this is too damn good. Nobody's getting any. And then you eat all 20 triangles.
Can you do it with a circle?
You get out of my head! You get out of my head! Can you do it with a circle? Yes. Of course you can, because the circle starts there, right? And then there's another circle back here. And then everyone says, but that's not separated by a rectangle. Yes, it is. Because what's that?
It's a rectangle.
It's a rectangle. Now what is it?
It's a circle, sphere, circle, rectangle.
Circle, repeating to a circle, separated by a rectangle. Everybody cool?
Yeah.
So that's one shape we're going to deal with. The other shape we're going to deal with today, not yet, pyramids. Now, you've all seen a pyramid.
Yes.
You've all watched The Mummy. You've all seen pictures of Egypt. You maybe have been to Egypt, or you've been to India. There's pyramids in India. Or you've been to Mexico. There's pyramids in Mexico. There's pyramids all over the place.
Where's the pyramid with the big person face? Like
The Sphinx, Egypt. The Sphinx is in Egypt. Yes. Now, you people have all, we did a great definition of a prism, and we built it together. How is a pyramid different? So don't write it, try to formulate in your head, talk with your neighbor, a definition for pyramids. Just give everybody else a chance, sister.
I have exactly the definition.
What? Yeah.
I mean, I think it is.
One sec. I gotta do something.
Do you watch that? Have you watched that? Or you haven't watched it in 20 years?
No, I wash it, but I only watch it once a year.
Once a year.
Because I only wear it once a year. For picture day. Okay.
That's it?
Yep. All right. Who would like to try the definition? I think I should probably ask Ariana. Go.
It's separated with the same shape it started with. Like, if it's a triangle, then the bottom is a triangle.
Not quite.
Or the same sheet of 3D object starting with a triangle and is separated by a square.
Starting with a triangle separated by a square. But if I start with a triangle and I make this distance here a square, then I just have a prism. No, that's okay. I want you thinking about this. Murat. Okay. No, that's cool. Everyone agrees with what Murat said, right? It's got a shape on the bottom. She said a square, and then it goes up to a point. So let's Joseph? Square with triangles on every side. Must it be a square?
Rectangle with triangle.
Must it be a rectangle?
Well, yeah, you can't have a circle.
Pyramid.
You can't have a
I'm
circle.
asking, is it?
Yes.
All right. So let's tidy this up. Oh, sorry, Vanessa, did you have something you wish to add? Or are you just waving to be nice like a princess? Okay.
Oh, okay.
So do we agree that it is a 3D object?
Yes.
We do because we've all seen pictures of them and we can see that they have 3 dimensions.
Is that an O?
It's an O. An 3D object. Now, what part of it is the same as a prism? Does a pyramid have to start somewhere? Yes, right? Okay. Starting with a shape, right? Starting with a polygon. Does that polygon repeat? There you go. The bottom is a rectangle, yes? What happens? The sides all go up in an angle, yes? So what happens to that rectangle?
It bends.
Doesn't bend.
It goes.
What happens to it? Expands? So if it expanded, then all those pyramids in Egypt would be sitting like this. That would be cool. That's what they did at the Louvre. I'm going with that in a minute. What really happens to that bottom shape? It shrinks to what?
A square.
That point is really nothing, isn't it? All right? So it's a 3D object starting with a polygon, which repeats, but doesn't stay the same at the end, shrinks to what? To really nothing. Everyone agree? So, could I start with a square on the bottom? Same size, yes? Now, if I go up 10 meters, is it going to be the same size square? No, it's going to be smaller. Then if I go up another 10 meters, it's going to be smaller and smaller and smaller and smaller, isn't it? And it's going to make a pyramid shape. Toby. Of course.
So you drew the half of the rectangle.
Don't worry.
Is that
I'm starting to collect because I'm sick and tired of this.
collect what?
The times you guys go to the washroom, because I'm tired of people leaving while I'm teaching and then coming back and saying, "Oh, gotta."
What about water? Or
Don't
after
care.
you're done teaching?
Don't care. When I'm done teaching is when you leave. Here we go. Kinda.
Okay.
Could I start with a triangle? And that triangle would repeat, wouldn't it? It would go up to a point. But it would be a triangle on the bottom. Yeah? Could I start with a hexagon on the bottom? It would just shrink and we'd go up to a hexagon. Can I start with a circle? And what would I go up to? It would shrink and make a cone. Everybody understand?
That just looks like, these look like squares with splits in the middle. Like there's the bottom left one. Isn't that?
That's a circle on the bottom and it goes up to a point.
The bottom left.
Bottom left, that was a triangle. That's why it's cut across the bottom. The square would look like this, right?
Is that a prism then?
No, these are all pyramids because they come to a point. Now, must the pyramid, which we said started with a shape, just like all the prisms, right? And that shape repeats. So, we need to name that shape. But it can be any shape. So what should we call the shape that we start with, Murat? That is the base. Because it is the basic shape we start with. It is not the bottom. Does everybody understand that? This right here is the base. And I wrote that in big on purpose because it is the shape we start with. Everybody understand? The reason I'm doing that is because of this. If you say the base is the bottom, then this pyramid which exists at the museum in Paris. There is a giant glass pyramid. You've all seen it in very many movies, the Louvre. Outside is a giant pyramid that is going point down. If you say the base is the bottom, you would say that was the base. But that point, in reality, doesn't really exist, does it? Because that single point does not have a length, a width, and a depth. So this is the base, because that's the shape that shrunk down. Is everybody with me? I'll give you a more useful definition for you people. If you go get an ice cream cone, it looks like that, correct? Right? Agreed? And the ice cream sits on the cone. Agreed? If you say that is the base, that's cool, right? But it's not, is it? Because what's the base? The circle, yeah? So if you insist on the circle being the bottom, then your ice cream cone would have to look like that. And that would be really hard and messy to eat because the ice cream would all fall out. Everybody understand? Base is not the bottom. Okay?
It's the top?
No, it's the shape that you start with.
So the flat part of the shape.
Except on a prism, every part is flat. It's the shape that repeats. Everybody cool? All right, let's apply this now. We're going to draw a cereal box. So everybody, you've all seen a cereal box. You've seen them on the shelf. They look like that. Agreed? I'm going to call this cereal Mattios.
Because your name's Matt.
Exactly, because my name's Matt. Everybody agree? Okay, now, does a cereal box have 3 dimensions?
Yes.
Absolutely correct. Of course it does. You can see it. What would you call this measurement on the cereal box? You would call that the height. Why? Because when it's sitting on the shelf, that's up and down is how we measure height, correct? Okay, what would you call this one?
Base. Length.
Okay, just let's stop. Ariana wants to call it the base. Just stop. Joseph wanted to call it the width. Do we have any other names for that you want to call it? Pardon? You want to call it the length. Okay. There's one other dimension. Where is it? It's this one right here, yes? Joseph wants to call it depth. Anybody got another name for it? Geo. You want to call that the width. So if Geo, I'm just going to change color if you don't mind. Geo wants to call that width. If that's W, then this must be what? Must be length. Is everybody cool with that? Now, I'm getting to that. How do I find the area of any 2-dimensional figure? Length times width. Agreed?
Because that
Okay.
would be the base.
So 5 times 2, if that's length times width, what's the area?
10.
Okay. 2 times 5, what's the area?
10.
10. Does it matter?
No.
Okay. That is because multiplication is what we call commutative. Doesn't matter what order you do it in. Which means, since I'm finding area here, and area is all about multiplying, does it matter what these are called? Absolutely not. So, let's stop for a sec. We're going to do 2 things here. The first thing we're going to do is this. Let's assign those 3 measurements sensibly on our cereal box. Where would the 8 go? On the depth. Agreed? Because that's the shortest distance of a cereal box, isn't it? Okay. What would you call this one?
24.
24. And what would you call this one? 40. Everyone agree?
Yes.
And now if we were to name these sides, height, we all agreed that height was up and down, yeah? Okay. What happens if I lie that cereal box on its side?
Then it's going to be the...
What's the height now?
The height is 8.
The height would be 8, wouldn't it?
Yeah.
So, do we need length, width, and height?
No.
Is that integral?
No.
Or does length, width, and height depend on how we're looking at the object?
Depends on how we're looking at it.
Depends on how we're looking at the object. So should we remember that length and width and height are not things on the object, but concepts or names given to things on the object? Does everybody understand? Because if I stand up, my height is feet to head. But if I lie down, ground to top, my height would be my belly, right? And that's not my height. Everybody cool? Okay. So now I'm going to color 3 sides of this. There's a rectangle, yes?
And that's a prism, right?
That is a rectangular prism. How would you find that yellow area?
On the back?
40 times 24. Does it matter which is length and which is width?
No.
No. How would you find the blue side?
8 times 24? 8 times 40.
8 times 40. Agreed? How would you find the green side?
24 times 40? 8 times 24.
24 times 8. Everyone agree? Now, if I split them into 3 rectangles, you can all do it in your sleep, yes?
Yeah.
But now they're together. So what do I need to do with those 3 numbers?
Times them.
Add them.
Don't we
Now,
solve the multiplication?
is there a yellow rectangle somewhere that we can't see?
Yes, in the back.
Is there a blue rectangle we can't see? Yes, on the left. Is there a green rectangle we can't see? Yes, on the bottom. So what must I do to all of that? Times by 2. Now that is what is actually happening. If you look on your data sheet, you are given this formula and told HLW, told where the HLW are. Will HL and W change? As long as you turn the shape, it changes. So knowing the formula is no good if you don't understand that they are going to move around, which is why I show you this. Oh, wrong day. You guys are D. Which is why I show you this first. Everybody cool? Now this is just, there's your WH, HL, and LW, isn't it?
Yeah.
Okay? So the formula exists. This is how we use it. Everybody cool? Now, does everybody understand this math? I do that times that, plus that times that, plus that times that, and then the whole answer is times 2, correct? Everybody get out your calculator and tell me the answer to this. Do not yell it out. Do not yell it out. If you already know it, just chill and let everybody else have a turn. Zach, don't say a number right now.
He's going to say a number.
Or, there we go. There we go. Calm down. Do you guys both have the same number?
No.
Interesting. Stop for a moment. When everybody has a number, I would like some people, without yelling out the answer, let me call on you for you to tell me the answer you have. Just chill, brother. Whew. All right.
Wait.
I'm waiting a moment. Okay. Zach, what do you have for an answer? That is not quite right. It is the right numbers. You want to finish it up, Dan? Centimeters squared. Now, stop for a moment. Stop for a moment. Stop for a moment. If you try to punch that all into your calculator at once, it's a crap ton of buttons, yes?
Yeah.
Right? Is it possible, like when you're texting, you might hit a wrong button?
Yes.
And when you push equals, your calculator is going to give you an answer based on the buttons you pushed, right? 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 Who do you believe? You're going to believe your calculator every time, aren't you? Let me give you a piece of advice. On long calculations, estimate. This is pretty darn close to 25, isn't it?
What?
24 is pretty close to 25, isn't it? What's 4 times 25? 100 plus a 0. This is going to be pretty close to 1,000, isn't it? Does everyone agree? Don't go to your calculators. 8 times 40, we can do that. 8 times 4 is 32. And a 0 is 320, yes? And this, 25 times 8, right, is 200. Agreed? 320 and 200 is 500. Close, correct? 500 plus 1,000 is 1,500, correct? 2 times 1,500 means this whole thing should be pretty close to 3,000, shouldn't it? Took me 2 seconds to check that with estimating. Now I punch into my calculator, and let's say, now Ariane, I'm not picking on you, but you got like 1,900, didn't you?
1,600.
1,600. So when Ariana punched into her calculator, she got that. But if she took 2 seconds to round all this off and estimate, she would have known she would have needed to be close to 3,000, yes? So would you risk handing that in as your right answer? No. Does everybody understand?
Yes.
Think back to your old textbooks. The first thing that every textbook question said was estimate, then calculate, yes? And how many of you actually estimated? Not one of you put your hand up. You go straight to your calculators. Which is really easy when it's a one-step equation, isn't it? But when it's a ton of buttons, it's easy to screw up. Everybody with me?
But 40 times 24 isn't that.
No, it's not. 40 times 25 is. That's why we're estimating. Because you can do 40 times 25 in your head. Right? 4 times 25 is what? Oh, come on. Is everybody cool? All right, now, turn the page over. There's a mistake here. This is the question that came from the pre-diploma book, not yours. So, we're going to change this slightly. It is no longer a rectangular pyramid, it is square. Aight? Everybody cool? And it is no longer 48 because it's a square, so it's just 32 on the bottom. And the height is 65. Everybody agree? Okay. So let's draw it. If it's a square-based pyramid, it starts as a square, correct? Now, since we're drawing it, are we allowed to draw that base at the bottom?
No.
Since we're drawing it? Sure. So how long is that side?
It's
32. How long is that side? 32. No, the base dimensions are 32 feet. So we start from 32. Everyone agree? And since it's a pyramid, it's going to go up to a point. Is everybody cool with that? Everyone agrees? Okay. Now, you draw a triangle on the front and then just connect back to here. Everybody cool? Now, if I blow this pyramid up, and you did this a lot when you were a kid, your teachers all gave you a thing that looked like this. And it had a little tab there that you put glue stick on, and a little tab there that you put glue stick on, and it was cut into these pieces, and you fold it and you made a cube, right? You all have done that. Okay? Well, if you do that with the pyramid, what the bottom is that, yes? And that would be 32 by 32, wouldn't it? Okay? And then there'd be 4 triangles. And since the bottom is 32 and 32, all these 4 triangles are the same, aren't they? Okay. So the surface area of this pyramid is this blue shape. What is that?
32.
Well, what shape is it?
Square.
It's a square. Plus, how many triangles?
4.
4 triangles. Agreed? How do you find the area of a square?
Times it.
Length times width, but in a square, aren't they both the same? So I'm going to say that this is b for base times b, which is b squared. Agreed? Everyone agree? That's going to cover the blue. Now, 4 triangles. What's the formula for the area of a triangle? Base times height divided by 2, correct? Now, if there's 4, what happens to that 4 and that 2? 4 divided by 2, which is what? 2. So this whole pyramid must be the base squared plus 2 base times height. Right? Because the divided by 2 is canceled out. Everybody cool? Now here's the problem. Where in this flat triangle would you say is the height? Murat. From the middle point here straight up to there, yes? That's the height of the triangle, agreed? Is it the height of the pyramid? No, because this red line is going to go up the side of that pyramid, isn't it? Agreed? But we've been told the pyramid height is 65. How would you measure the height of the pyramid, not the wall? What would you do, Murat? From that point straight to the ground, agreed? Now what do you know about that point on the ground? It's right in the middle, isn't it? Which means how long is that? So how long is it? 16, agreed? Half of 32. And how tall is it? No, read the question. 65. Now I need this red line, don't I? I have to find it, don't I? Now notice, please, this is 65, this is 16. What angle do you know is there? Not parallel. Perpendicular. It's 90, yes? I need this red line, don't I? Because that red line is the side of the pyramid, but it's also the height of the triangle. So, can I call it height, or does that make it confusing? It's confusing, isn't it? Because the pyramid has a height, it's this black line. So we have to give this line up the side a new name, which is slant. Slant is the distance up the side of any pyramid. Now, in grade 7, did you learn the way to tell the third side of a right angle triangle? Not quite. How do you find the third side of a right angle triangle? Yeah. Except I'm never going to call it that, because if I change the letters, then you kids tell me you can't do it anymore. It's Pythagoras. It is this guy squared plus this guy squared, and then what do I do to that answer? Not divide. I square root, right? So this red side is the square root of the other two sides. Yes? 65 squared plus 16 squared. Don't push square root. Use your calculator right now to tell me what 65 squared is. What is 65 squared?
4,225.
4,225. Agreed?
Yes.
What is 16 squared?
256.
256. What is 4,725 or whatever it was plus 256?
4,681.
4,681. So this side is the square root of 4,681. Is everybody cool to there? It's not. It's all math you've already done. But I warned you, grade 10 puts it all together. Everything on this page you have already done. Is everybody cool to there? In grade 7, you would square root that and get an answer, wouldn't you? And it would be a whole bunch of decimals, yes? Everybody cool?
Isn't there a number on the outside?
Okay. Now, I did this in red. Now, everybody go ahead and square root that. And it's going to give you a crazy big number. Right. Fills up your whole screen. How many decimal places do I like? 2. So what would this be? 68.41. For 2? Okay, I believe you. Is everybody happy to there? Now, if this red line is that, and this red line is that, then do I know this? What is it? 68.42. Can I then fill in this formula? What is the base of our triangle, of our pyramid? 32. And I'm supposed to square that base, aren't I? So 32 squared plus 2. What's the base? No, just the base. What is the b? No. 32 times, what's the red line? 68.42. Is everybody with me? Did we do anything new? We just put together stuff we already know. Is everyone cool? Now, when you punch that into your calculator, that's yucky, right? It's barfy, isn't it? But you can have a good idea where you're going, can't you? That's close to 30, isn't it? 3 times 3 is 9, and 2 zeros is 900, correct? That's pretty close to 900, yeah? 2 times 30 is 60, right? And this is almost 70, isn't it? 60 times 70, 6 times 7 is 42, and 2 zeros is 4,200, correct? 32. Add them up, and you should come up to around 5,100, yeah? Now go to your calculator. 5,402 point what? 88. 1 second to estimate, guaranteed you're right. Everybody cool? Now, I'm going to give you a warning here, and I'm going to write it in a color I never ever use. I'm going to choose a color, so it's so important that you will never forget it. Bright pink. Sorry, Pythagoras to find slant.
That's so much.
Always. I warned you about that. In grade, all the way along, we would have told you, find the hypotenuse. And that was the only thing you did. And we gave you the gold star. Find the area of a square. You did 32 times 32, and we gave you a gold star. Find the area of a triangle, base times height divided by 2, and we gave you a gold star. And we made you do it 50,000 times. And you thought you were brilliant. But then when we ask you to put it all together, everyone's like, what? Now, when should we have done pyramids? Right when you learned triangles, because it's right there in your head. But no, we do it 10 years. Well, I know you did, Moret. You're from another country. All right, now let's try and put it together. Now I got a cone, yes? What does a cone look like? How does it start?
It's a circle.
Circle. And I'm going to use dots at the back of the circle, because we wouldn't see that part, yes? And then it goes up like that, yeah? Everybody agree? So we know that the surface area is everything we can see. So we know this is a circle for the bottom, which is what? How do we find the area of a circle? Pi r squared. Yes? Everyone agrees? But that only covers the bottom. The rest of the cone is a section of a circle. It's not a whole circle. It's a section of it. Well, I still need an area of this, don't I? Yes. So I must be adding a section of a circle. If I'm finding any part of a circle, what must be part of the equation for its area? I must need, not diameter, I must need a radius. What else must I have? I must have pi, mustn't I? Because it's a circle I'm dealing with. So I'm dealing with pi, I'm dealing with radius. But it's not radius squared. What was the other length we needed in the rectangle pyramid? We needed a slant. Isn't a cone a pyramid? So we must need slant somewhere, yes? Where do you think slant goes? Right there. Everybody cool? Everybody cool? Now, do you have to memorize that? Do you think? That hurts that you guys think that. That's crazy talk. What's right there on your sheet? The same sheet I gave you at the beginning of the year and said, don't lose this, you're going to need it all year long. Isn't it on there? They're at the front because I keep a spare set, because keep this and don't lose it is a confusing instruction to many grade 10 students. I try to keep it as simple as I can, but apparently there's a simpler way to say keep this and don't lose it than keep this and don't lose it. Sure. Try to keep it and not lose it. So you don't need to memorize it, do you? Do I have a radius? Where is it? Where does the radius live? In the middle. It is how long? Read the question. 15. I also have a height. Where would the height of the cone be? From the point to the bottom, yes? How big is that? 22. Now, what is missing? No. I'm missing the slant. What always finds slant? Pythagoras. Do I have a triangle in this cone?
Yes.
What is it? It's 22 and 15, yeah? So this Pythagoras, this hypotenuse, must be the square root of what? 22 squared plus 15 squared. And then I square root the answer. So that's the square root of 709. Right? So what is it?
709?
Yeah. What is the square root of 709? Stop. Stop. When you punch that in your calculator, you get a big, ugly number, yeah?
Yes.
Yeah, you do.
502,000.
No. Square root 709.
That's what I
You squared 709. What is it? It should be around 26 and a bit. 26.627? So 22.63. Everybody cool? Or 26.63. Everybody good? Now, that is my slant. Can you now fill in your formula? Pi, what's r? I've got it written right here. 15 squared plus pi, what's r? 15, not squared, 15 times slant, which we know is 26.63. Is everybody cool? Yes. If you write the steps down, you can't do it wrong. It's impossible. Now, stop for a moment. This is hard to punch into your calculator. And this is where things are going to get weird for some of you. Everyone with your calculator do 15 squared. Just 15 squared. It's 225.
Yes.
So this is 225 pi. Agreed? Because 15 squared is 225. Okay. Now everyone with your calculator do 15 times 26.63.
399.45.
399.45 pi. Agreed?
Why pi?
Well, because the pi is still in here, isn't it? Now, if this was 225x plus 399.45x, what would you do with 225 and 399? Add them. So what do you think you're going to do there and there? Add them. What is 225 plus 399.45?
624.45.
624.45 pi. Yeah. It would be centimeters squared. Centimeters squared. Now listen to me. This is the best answer you can give me. There's a problem with that, though, because that's a math class answer. Could you go to Home Depot and say, I need enough paint to paint me a cone that's 624.45 pies square?
No.
You can't, can you? Right? So this is a math class answer. As you go further and further in math, you're going to leave pi as a letter. You're only going to deal with the numbers. Everybody cool? But in the real world, do we deal with pi as a number? We deal with pi as a rounded off number, right? Most of you want to use 3.14. Do not. Use your pi button. So, to do this on your calculator, I'm going to write out everything you need to hit. You need to go 15. Then all of your calculators have an x squared button. Then you need to push times. Then all of your calculators have a pi button. Use it. Then you must hit plus. And then does this order matter?
No.
It's all multiply, right? So anything. I like to go back to 15 first, times 26.63, times pi, then equals. And you should get, don't give me away. This is about 600, yes? Pi is about 3, yes? 600 times 3 is 1,800, correct? So I need an answer to be something around 1,800. And you get?
1,961.7.
Blah, blah, blah. Who cares? Is that a good answer? Is that close to our estimate? Are we happy, Tobby? It has a pi button. I'll find it for you later. It takes 30 years to go around to everybody and find their pi buttons. I'll find it for you in a minute when it's work time, okay? So stay cool. Everybody good? Ethan. That goes back to this x thing, right? If I have 3 x's plus 4 x's, that's x, 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 and then 4 more x's, that's 7 x's. So there was 225 pies and 399.45 pies to make a total of 624.45 pies. Do you remember that from grade 9? Okay. Everybody good? All right. Now, what's a cylinder? Or a pop can? What does a cylinder look like? What's on the top? Circle. What's on the bottom? A circle. And then we got straight sides, yes? Everyone agree?
Do you have an eraser?
I do.
That is scary.
Everyone agree? So, if I was doing surface area, how many of those circles are there? 2. 2. And what's the area of a circle?
Radius.
Pi r squared. Yes? And then there's the side, yeah? We already know that the side is just a rectangle, isn't it? So there's this. It's a rectangle. So this must be a length or a width, yes? Because it's a rectangle. If I stand it up, you want to call it the height. If I lie it down, is it still the height? Or is it just the same number? Same number. So you want to call this a length or a width, but we're going to call it a height because our cylinder is standing up. And then the width is all the way around, isn't it? How do you find the circumference of a circle? The pi r squared is the area.
Take a string and you put it around.
Pi, not pi r squared, pi times the diameter, which is how many radius? 2. So the rectangle is 2 pi r. That covers the round part of the rectangle. This part times what's this?
Height.
We call it the height. Everybody cool?
Sure.
If you write it out, you can't do it wrong. Do I have a radius from the question?
No.
Yes, I do.
Radius is
So what's the radius? Radius is 5 because the radius is half the diameter, yes?
yeah.
Do I have a height?
20 centimeters.
20. Do I have all the unknowns for this equation?
No. Yes.
2 pi, what's r? 5 squared plus 2 pi, what's r? 5. What's h? 20. Now, don't go to your calculator. What's 5 squared?
25.
What's 25 times 2?
125.
25 times 2.
40.
50 pi.
50. Is it 50?
What is 5 times 2?
10.
What is 10 times 20?
200.
200 pies. I got 50 pies there and 200 more pies. How many pies do I have? 250 pie.
Why do you pronounce it 50?
Because I do.
Okay.
Does everybody understand? That is the best answer in math class because it's exact. There's no decimals there, is there? We don't like decimals in math class. We want exact answers. But is that a real life answer? Of course not. A real life answer, we would have to go 250 times our pi button and get an answer. Now, what is the pi button? Is close to 3, yes?
Sure, yeah.
What's 250 times 3? What's
750.
750. So if our answer is close to 750, are we right? Yes, we are. And our answer is 761 blah, blah, blah. 785? Okay, I was wrong. Is 785 pretty close to 750? So we know we did it right. Is everybody cool? Yes? Now, Gurveer, I noticed that you looked over at Gio, laughed, and said, I'm going to ask him, and then put your hand up. Do you really think it's a wise question to ask me when I'm dealing with the whole class? Or is it something you should wait till I'm walking around and we can have it just between? There you go. Everybody good? All right, now, your assignment, and I'm giving you 15 minutes to do it, I want you to work out the surface area on the next 3 pages. I think it's 30 to 32. Now stop for a moment. Stop for a moment. Some of them you will have a formula for. Some of them you will not. I showed you in your notes the way to do it that always worked, didn't I? Yes. Okay. Now, if there's no formula, you've got to use your brain. Everybody understand? Remember, before I showed you the formula for this, we worked it out by adding up all the shapes. If it works once in math, will it always work? So will this always work no matter how complicated the shape is? Yeah, you just keep adding them up. Everybody cool? So when you get to these questions, this one's really easy. Does that one have a formula?
No. But yes.
Sure it does. That's a rectangle prism, right? That's 2 WH HL LW, right? That's easy. What happens in D? Can you do this formula?
No.
Technically you can because this shape is over here, isn't it? There's just some extra. What math adds extra? Guys, there's only... Come on. I did that on purpose. Addition. All right.
So you add 12 and 4?
You will be figuring that out.